hope I don't get any emails. All right, so Molly asked the question, because there were some in the homework about rewriting expressions. As one involving sine of theta and cosine of theta. And that's where I was saying, I think this is kind of common sense, but you might not have understood what the question was asking. Basically, this just means that you're only using your sum or difference formulas. We're not solving or anything. You're just using them so there's not a 2 there anymore. Or, in one of them I'll show you, you could do something higher than a 2, okay? So, if I said, let's rewrite sine of 2 theta plus cosine of theta, this is okay, but how could I rewrite that? So there was no longer a 2 theta in there. Plus cosine theta. And I suppose we could try to simplify it one step more if we wanted to, just by writing it in factored form. But the instructions were only to rewrite as one involving a sine theta, cosine theta, and I've done that. I have all sine theta, cosine thetas. I guess you could do this if you wanted, but really, here or here, you have done the task that I asked you to do. What you also could do, though, let's do another one. What if you saw this? What's that? You would just try. Okay. Awesome. He said, can't you just rewrite this, because if I have only a double angle, can't I just rewrite this as sine of theta plus 2 theta? Okay. Now let's just go ahead and rewrite this. There's different options that we could use because we have 3 of them. I'm going to just do the one with both of them, and then we could always swap them out later if we wanted to factor. But once again, I'm not super concerned about how simplified you go. I'm just concerned that could you think of what Chase just said to rewrite this? All right, so what was the first cosine double angle? Cosine squared. Okay. Now, this is where you're not going to probably like this very much. If I wrote it this way, because I still have a 2 theta in here, don't I? Yes. Then I want to use a sine sum formula. All right, so this would be, doesn't it say sine of u times cosine of e? Yes. Okay, so I'd write sine of theta times cosine of 2 theta plus cosine of theta I just was using the sine sum formula on this. I already did that. Okay. So, am I to where I have just sine of theta and cosine of theta yet? No. So then you'd actually have to go through one more step, and this is where I was saying I wouldn't be picky about how you simplify that then, because I'd then have to go through and rewrite these. What? So once again, I could choose, but I could do like the cosine squared theta minus sine squared theta. Now I've gotten rid of the 2 theta in there. And then this one would be 2 sine theta cosine theta, right? Okay. So, does it look pretty? No, it does not. However, was I able to rewrite using multiple formulas to get rid of the double and the triple angle. I suppose you could go through then and try to distribute and see if you could factor out common factors and things like that. But I'm just mostly looking at, do you know how to get rid of 2 thetas or 3 thetas or 4 thetas using double angles or some formulas? Okay. Can we do the what? You could, and then but then you'd have to use it again. Do you see what I'm saying? Because then when you subbed it back in, there'd still be 2's. But then you could do it again, like no matter what, you'd have to use it twice. Okay. Let's do one more example solving using a half angle, please. So would you get your half angles handy? Okay, so what I would like us to do is we're going to solve let me just make sure I'm doing the right one. Would you make those squares? Okay, so this is just cosine squared. This is x over 2, which you can think of as u over 2, okay? And so let's just remember what these things mean. This means you're going to take the sine of x over 2, and then you're going to square it, okay? So what we're going to first do is rewrite the sine of x over 2, and that's the part where we're going to use the half angle identity. So what is the sine of u over 2? Plus or minus square root 1 minus cosine u, but I'm going to write 1 minus cosine x. Hey, by the way, are you noticing on the half angles that they're even sines and cosines inside here? That's a cosine always. And then divided by 2, right? And I'm not going to do anything over here. Oh, wait a second, though. This was squared. So I'm supposed to square it. It is. Because what does squaring a square root do? It just removes the square root. Okay? So this is sine of x over 2, but then squared. So I put the sine of x over 2 formula in, and then I squared it. So now I have, and by the way, that I'm going to remove then that plus or minus because I'm squaring it. I'm going to make it positive. Okay, so give me your thoughts now. This becomes something similar to what we've done before. We want to get a 0 on one side. And I'd also like to get rid of that divided by 2. How could I get rid of the divided by 2? Multiply both sides by 2? Okay, so we're trying to solve. I know. I'm going to give you some parameters. We're going to solve on 0 to 2 pi. What do you think? What should I do now? Subtract the 1 and add the cosine to get a 0 on this side? Sure. I like doing this way because you know how I'm weird about the leading coefficient being positive. But you can. Hey, this looks like some things we've been doing. We're going to factor this. What does this factor into? 2 cos.
That is always correct. Yeah.
Okay, so when you're multiplying this out, we have to check the middle term. We know that 2 cosine times cosine is 2 cosine squared. And we know that -1 times 1 is -1. But if I had flipped those around, the middle term would have been incorrect. So check by multiplying. This would give me a positive 2 minus 1, which gives me a positive 1 cosine term. All right, so we set them equal to 0 then. So 2 cosine x minus 1 equals 0. That would mean where cosine x equals positive 1/2. One of them is pi thirds. 5 pi thirds. And then we're going to set cosine of x plus 1 equal to 0. So this is where the cosine of x equals -1, which is pi.
Holy crap. We did it.
We did. So that's some solving.